The Lucas well came in gushing oil 200 feet above the top of the derrick. And for 10 days until they could get it capped, it gushed 100,000 barrels of oil per day around the countryside. Within 2 years, there are almost 300 producing wells on Spindletop Hill. With the discovery of Spindletop, oil had suddenly become very plentiful. You must remember this is the early 1900s. The automobile was becoming popular. The airplane had just been invented. And ships were being converted from coal to fuel oil. All of a sudden, oil was a cheap, plentiful energy source. Dozens of companies were formed to produce the oil found at Spindletop. From these very primitive beginnings here at Gladys City, we find the roots of many modern oil companies, such as Sun, Texaco, Gulf, and Mobil. As you can see, it's appropriate that we start this series here at the Gladys City oil boomtown on Spindletop Hill. I'll be showing you the nature of crude oil and natural gas, how it forms and is trapped underneath the surface of the ground, how you explore for it, how you drill and complete a well, and how you refine crude oil to a finished product. So come on, let's get started. Have you ever seen crude oil at the well site? This is what it looks like. Crude oil with natural gas bubbling right out of it. A lot of water. These are all crude oils, and as you can see, they exhibit a wide variety of characteristics. We often describe crude oils on the basis of their density or weight. We convert the density or weight into a number scale, which is called degrees API gravity. For example, pure water is 10 degrees API gravity. This is very light oil. It's 45 to 55 degrees API gravity. And as you can see, it's very fluid. This is more normal oil here. It's still fairly fluid, dark in color, is anywhere from 35 to 40 degrees API gravity. This is very heavy oil. It's very, very viscous and dark in color. It is anywhere from 5 to 20 degrees API gravity. When we take a look at these oils, this is the least valuable, the heavy oil, and this is the most valuable, the light oil. There are three fundamental types of rocks. First, there's an igneous rock. An igneous rock has cooled and crystallized from a hot, molten liquid, such as lava coming out of a volcano. The second type is a metamorphic rock. And a metamorphic rock is an original rock that has been affected by an enormous amount of heat and temperature to change it into a metamorphic rock. Neither the igneous nor the metamorphic rocks contain much in the way of gas and oil. The third type of rock, sedimentary rock, has a very complex history. It's a rock which was originally exposed on the surface of the ground, and the processes of weathering, both chemical and physical, break it down into its individual components, such as sand grains. And then these particles are carried for some distance by a river, by wind, by waves, and they are deposited into what's called a sedimentary rock deposit. So as you can see, a sedimentary rock has a very complex history. It's a pre-existing rock which has been broken down and transported into another area and deposited to form a sedimentary rock. It's the sedimentary rocks that hold the important gas and oil deposits. In fact, when we take a look at the crust of the earth, we see that it's usually covered with some thickness of sedimentary rocks such as this. Let's go down into the earth and take a look at what's below these sedimentary rocks. If we go deep enough into the earth, we encounter solid rock. This solid rock is igneous or metamorphic rock, and it's called basement. That's a good term, because basement rock does not hold gas and oil. And if you're drilling and hit basement rock, it's time to stop. So in a typical cross-section of the Earth's crust, we have about 5,000 feet of sedimentary rock on the surface, and then we hit this basement. The thickness of that sedimentary rock varies quite a bit. In some areas it's very thin, in other areas it's very thick. But it's in that sedimentary rock that we find the gas and oil deposits, and that's what we're most interested in. So let's go back up and take a closer look at those sedimentary rocks. This is a sandstone deposit. Sandstone is composed of sand particles. Can you think of some ways in which sand is deposited today? I can think of about 3 different ways. This is sand, carried by waves and deposited on this beach. If this beach is buried deep below the subsurface, it'll become a sandstone layer. Sand being blown by the wind and deposited as sand dunes. There's another way in which we can deposit sand. Sand being carried by this river. There's another way in which sand can be deposited. All 3 of these environments, beaches, dunes, and river channels, can deposit sand, which can be buried deep below the surface of the ground and become hard sandstone rock. This is a very common sedimentary rock, limestone. Limestone is composed of calcium carbonate, which is commonly called lime. This is a very important rock because limestone in the subsurface can hold gas and oil.